out microscopic volumes of silver, silver is really expensive because there are very few reserves, like big mines that are worth digging up, of silver. Resource is the item that you value, some mineral, some element, some compound. And the reserve is pockets that are worth extracting. So we're gonna.
Silver shows or pockets of silver or things.
Silver what's in the what?
It said silver shows that.
Yeah, so silver's a great example where the resource can be really common, but the rarity of reserves is what sets the price. Okay. Have you checked the sound quality on those?
I haven't.
I'd like to see if this new microphone is helping or not. We should check that sometime. Maybe you can remind me after class one day. We'll do a little experiment with it. Okay. Number 14 asked about strategic metals. Fun fact, if the real planet were a real game of like Risk or something, you should take the United States. It's seriously like the best piece of dirt on the planet. In terms of like national boundaries, maybe with the exception of Russia, there is no rival to the United States' pile of resources. A great deal of our economic success is, I guess you would say, the luck of the draw and where the big ships landed. This piece of land is spectacular. From sea to shining sea, we have seafood, lumber, farmland, water, and almost every metal required for a modern economy. In terms of physical resources, the United States is a spectacular and diverse collection of resources. However, there are just a few things we unfortunately don't have. Those are called strategic metals. And I think you have to know them, and I know it's a lot, so I know it's kind of a hardship. The strategic metals are those which we need for our economy, but cannot extract ourselves. So we make what are called strange bedfellows. Surprising international relationships. Like most Americans can't find Kyrgyzstan on the map, but Kyrgyzstan is a political superpower because I believe they are the world's largest exporter of mercury. The United States has an unbelievable volume of economic relationships with Australia, Guinea, and Jamaica. They give us aluminum. That's what bauxite is. That's the number one resource that we don't have enough on our own, so we got to make friends with other people. Bauxite is aluminum ore. And I'm sorry, but for some reason that's been on the AP test like 5 times. So we're going to call that a vocab term. Bauxite is the ore of aluminum.
What is ore?
Ore is when a rock is mixed with your metal. I'll show you some copper ore later today. Japan is considered to be one of the most resource-poor nations on Earth. They have to import almost everything for their economy. So they're what's called a value-added economy. They take raw ingredients from the international scene. They engineer them into cool products, and then they sell them having engineered and assembled those raw ingredients. Japan has the most strategic dependency of any modern nation. They don't produce basically any of their own raw goods. And in your generation, we're seeing a giant shift in the international strategic balance in resource extraction. You see, our economy today is largely fueled by small electronics. Small electronics rely on really tricky and unique metal alloys to make all the little its and bits of these things. So just like coal became really valuable when we started burning it, and petroleum became really valuable when we figured out what to do with it, there is a new rising resource right now. It's called rare earth elements. Some people call them just rare earths. You can see I wrote it at the bottom here. The rare earth elements are these right here. They were not economically valuable at all up until this decade or so. They've become extremely valuable. A lot of them are only found in 1 or 2 countries. Sorry, was there an exception? Did I skip some obvious ones? Which one? Yeah, silver and gold. Those have been around for a while. Tin and lead. Okay, so in addition to some of the more obvious ones, this area includes rare earths. There we go. And stuff that used to be irrelevant, metal that people used to just like dispose of from their other mines, have become extremely valuable, like much more valuable than precious metals. Now, funny story is the United States actually has a spectacular deposit. We have a rare earth mine, but the biggest one in the United States is smack dab underneath protected land in the Sierra Nevada mountains. So because of our stupid environmental legislation, we'll never get to it. One of the only other countries with significant supplies of rare earths is China. And they're like, wait, you mean you need all of this stuff to run the economy of the future? And they're keeping it. China is building these massive stockpiles of rare earth elements. I don't know if you've heard that the United States and China have kind of tense relationships about trade policy and economic valuation. How the Chinese government sets the value of their currency to favor export and not import or whatever. So there's a lot of really tense political infighting about that Chinese trade policy because of that issue of trying to figure out who's going to do what with the rare earth supplies that China has now. I have a feeling that in your generation, this will be like another gold rush. And I think it's going to be a really interesting social landscape when we find other countries that have rare earth supplies that we can make relationships with. Just to put that on your radar, it's not too much else to say in environmental science, but I'll bet you that comes up in the next 10 years. Yeah?
Does our environmental consciousness and our strict laws about exploiting natural resources in America make mining here more expensive than importing?
The import thing is probably not a single answer, but the first half of your question is for sure a fact.
That makes it more expensive for us.
That period is for sure. Undoubtedly, environmental protections raise the cost of extraction.
So that's why we choose to import more often than mining?
Yeah, I mean, another way of saying it is we outsource the environmental harm. You know, if the whole world had the same environmental protections and the same worker rights, it would all be the same price, and you'd add shipping, so you wouldn't need it internationally. So where we leverage benefit is in places where you don't have worker protections and environmental protections. Cotton?
I remember when I was in Perth in Australia, my friend.
The largest aluminum exporter in the world?
Yeah, it was like almost impossible to find a place to stay. People from all over the country were moving there to get a job mining.
Really?
Yeah.
For aluminum at the time? Far out. You know the name of the company that was hiring? Is it Alcoa?
I'm not sure.
What?
Are we ever going to get to that zero level mine that's like safe? Like is that like controversy that's still ongoing, or like it's a set thing like when it's safe?
It seemed pretty controversial a couple of years ago, but I think it was sort of frustration because it is so set, like, no, we're never going to get it. But I don't know. I mean, you never say never. And in politics, like, slavery's over, unless we really need it. I have a feeling that you can politically push thing either way, you know? Yeah?
Do you ever think about putting nuclear waste down abandoned mining shafts, or is that
No, that was the leading plan. Yucca Mountain had been a closed mine. You know, you want to put it in a place with known geology, and it helps if there's already tunnels down there. So the top candidates for nuclear waste storage are all used mines. The flip side of that is that mines are usually abandoned as they become less and less safe for storage. So there's not a lot of mines that have the structural integrity to be a nuclear repository. All right. So number 15 is a 3-star study goal. I want to talk about this, the impact of mining and processing ore and before we jump into that study goal, I want to remind you a couple of things about mining. First of all, remember that when dirt's been underground, it's been away from oxygen. So when you surface dirt, it oxidizes, and when you mix oxides with water, you get acids. So the first thing that I want to remind you of is any type of mining creates water pollution because of the acids that result when oxides mix with water.
That's like not even pulling on metals. It's just like if you dug like 100 feet down and just pulled up how happened.
Yeah, I don't know the number of feet, but yeah. It's not just what you're pulling up. It's that a certain percentage of all soils, when you get deep enough, will oxidize at the surface. I'm sure that there's huge differences in soil types, so some will oxidize more than others, of course. But it's an inherent consequence of things being buried. The second thing I want to remind you about mining is just like food production, most of us have no idea how big the scale is. You know, you ask an average person in a supermarket what they think the average American farm is, and they'll say, oh, 4 to 10 acres. And the average American farm today, I think, is somewhere like 2,000 or 3,000 acres. And it might be 10,000 acres, but I'm not sure. Likewise, when you ask somebody, what is the average budget for a mine in the United States, they'll say, like $1 million or something. And I'll bet you that the budget is in the billions of dollars as an average, because mines are just much, much, much bigger than what you probably visualize. We hide them in the landscape, so most of us don't drive by them, we don't see them, but they're a lot bigger than you think. So for the first, I'm going to give you 1, 2, 3, 4, 5 types of mining. You would need to describe them and understand their environmental impacts, and then we'll do 3 types of processing. First is placer mining. Do you guys remember what a placer deposit is? Yeah, so there are sediment deposits left by moving water. Placer mining is when you sort that sediment. Placer mining is removing pools or stream banks. Are a lot of placer mines budget?
Mitigated.
Um,
I guess it depends on where, but
yeah, by mitigation you mean offset by other benefits?
yes.
I don't know about that. I don't know if we require mitigation or not. That's an interesting question.
I guess it depends on the area, right?
Yeah, I mean, I know that they're almost always reclaimed after the fact, so I don't know that if they have to mitigate before the fact. Yeah. Placer mining is when you excavate sediment deposits. So you sift through sediment, try to find what you're looking for. This is common for precious stones, like emerald, ruby, diamond, and also for some metals, especially gold. Almost all gold mining is placer mining. So these guys are sifting through sediment. They use water to sort it out. You speed it up so that the gravel gets tumbled, and the gold is heavy, so the gold stays behind. Ditto these dudes. You get the water moving. Do a little shimmy, shimmy, shake, and then that'll separate out the gold from the gravel. But nowadays, this is considered a small-scale tow-behind-your truck, one-man operation. And these are industrial placer mines. What they usually do is they reroute rivers, or they dam rivers, then they excavate giant volumes of sediment. There's been a big wave of placer mining in the tundra, extreme north, and this is an area where historic rivers that have now dried up because of global cooling, when it was much hotter on the planet and there were rivers running through the tundra, that deposited gold. And so there's a lot of placer mining in the extreme north. where you have to first of all dig a big hole so it'll fill with water so that you can get the liquid to separate the sediments. Inside that shed, they tumble the stuff like this. So that's your big tumbler behind the dude. Another place where there's a lot of placer mining is for gold in the tropics. And I gotta tell you, gold mining in the tropics is like the root of all evil. When I got married, I had to go really far out of my way to get this ring because it's made out of recycled gold because my wife and I were really freaked out to use commercial gold. Because a lot of commercial gold is like, you guys ever heard of blood diamonds? They're like diamonds that come from a conflict region where that extraction was used to fund heinous activities. So I've heard it said that roughly 50% of our modern gold trade internationally is sourced from illegal or conflict regions. You guys know what a gateway drug is? How like everybody starts using Oxycontin and then they move on to heroin because it's cheaper than Oxy. Do you guys know that, by the way, that we are living through the most rapid growth in the heroin industry ever?
Really?
Yeah, that's all because of prescription drug abuse. The prescription drug industry has made a bunch of opiate addicts, and prescription drugs are actually like really expensive because you're
Easier to get these days.
paying pharmaceutical companies. So heroin remains cheap, and as the relative to prescription drugs, heroin's much cheaper.
What's about pharmaceutical companies? They just start letting everybody have opiates.
You're not the first to mention it. Yes, yeah. So a lot of these things are either directly opiates or they act like opiates. So like people who abuse Oxy, like snort it or whatever, like once people get into that, then it's like, dang, I really like that feeling, but it's so hard to get Oxy. And then some dude in the corner is like, yo, I got smacked for like really cheap. Same thing. And so people usually move into heroin now. It's like an American. Have you guys heard this? Am I the only person that's telling you that? Say what, bro?
That's how Philip Seymour Hoffman died.
Oh, using heroin, yeah.
And a bunch of other stuff.
He was in rehab for 6 years and then he got back on.
I don't know the details of his life, but I have heard from many people that the heroin thing is like the craziest leading edge of the drug problem right now. Yeah.
So that thing's happening in Russia, but instead of heroin, it's crocodile. You heard about that?
It's getting huge.
I have heard of that.
Crocodiles are enormous.
It's not enormous, but it's
Gasoline
big people.
and meth. It's gasoline and then bath machiners and meth.
Sounds so good.
Yeah.
Dank ass.
Get me into that.
Oh, it smells so good. So bad.
So here we go. Placer mining in the rainforest is like the gateway drug to tropical deforestation. So, I don't know if you guys have heard, but like we're losing a lot of tropical forest. So, we do not lose tropical rainforest for logging. Just to be clear, very few of the trees in the tropical rainforest are valuable lumber. There's a whole bunch of like weird, curvy, awkward types of wood, a bunch of like fibrous, fast-growing trees, a bunch of softwoods, and a few really expensive, sought-after hardwoods. That's very targeted logging. It's not worth clear-cutting the forest to get a couple of those logs. Yeah, like that. So the way that it usually works is to make the first road cut and clear the first camp. That's usually illegal mines. You see, placer mining is really simple, it's really old, it's really well understood. You can do it in very small scales, like we did it for gold in the Sierras 150 years ago. If you can get like a compressor and a fire hose, you can blow away all the stream bank a lot faster. And so if you can get like a truck back there, you triple the efficiency. But it's a really simple, well-known method of getting stuff out of the mountains. Sorry, out of the earth. So we find that the normal progression in the tropics, mining camp, for placer mining, often for gold or for diamonds. Once the mining camp is done, then people move in for either the exotic animal trade or for the exotic hardwood trade, like mahogany and stuff. Then they do large-scale slash and burn for farming and ranching, and then comes the development after that. Thank you, but 2 seconds. A lot of those placer mines are really simple to run. So I can go to like a refugee camp and kidnap like 5 teenagers and tie them up with a chain. Drag them into the forest and say, hey, if you want to eat, get me some gold out of that riverbank. Once I have the gold, I can go, hello, wealthy, good-looking European. Would you like some nice gold bracelets for your partner back home? I get that money, and now I can buy my machine guns and ammunition and gasoline and chainsaws to go have my ethnic cleansing campaign or my regional religious battle or my turf war over grazing grounds or whatever. It's funny that illegal small-scale placer mines seem to be at the root of unbelievable human atrocities and environmental degradation. Like I said, the gateway to developing and deforesting remote tropical regions, and the primary economic driver of most of these remote third world conflicts. You've heard of conflict resources, conflict metals, the blood diamond thing. That's all. The Coney, what was that? Coney 2012? Okay, like everybody got on Facebook to save the world, and a fat lot of good that did. We all pretend to give a crap from our cell phones. Then we forget, kids keep dying. Wasn't that fun? Hey, but I got a cool t-shirt. It was great. Yeah, that's true. That military activity was primarily funded by the extraction of valuable metals that were usually sold to the developing world, to the developed world. Yeah. You know, I'm sure nobody wants to do it on purpose. And politically and economically, nobody would do it publicly because that would be a big embarrassment to them. So I think if we could show you that iPhone was using conflict metals in their iPhones, they would say, I'm sorry, Apple apologizes, we'll never do that again, that was an accident, bad. But one way or another, all that stuff enters the consumptive chain. You know, the average diamond is touched by something like 12 separate hands before it reaches the cutter. And so can you track the history of that diamond all the way to which mine? Nowadays, actually, in recent years, diamonds have become a much more legitimized industry. Up until 10 years ago, it was kind of no man's land free-for-all. I don't think there's any brand that can guarantee you that they are purely innocent. So, allow me to review. Placer mining, sort through sediments and placer deposits, precious stones and gold, sediment pollution in rivers, riparian habitat impacts, and the gateway entry point to tropical devastation. By the way, check it out. That's an illegal mine in Venezuela. Yeah, it is enormous.
That's from a plane?
Yep.
Wait, where? Everywhere?
What's up? I'm sorry, what? And were you asking something?
Wait, the whole like tan part?
Yeah, so that's all deforestation for a mine. I believe that was in Venezuela. By the way, I got to remind you guys, I think we've talked about this before, right? The tropics has no shortage of laws to protect nature. You guys realize that, right? It's just the challenge of enforcing those laws in a remote part of the world. You know, the narco traffickers don't go to the capital to shoot cops. The cops don't go to the rainforest to shoot narco traffickers. Everybody's cool. By the way, we'll also talk tomorrow about how one of the big impacts of placer mining in the tropics is mercury pollution in water. I have to explain this separately, so you may want to keep that in your notes about placer mining. So underground mining is probably what you think of from a movie like Zoolander, with like the black stuff and the chipping and the coughing and stuff. Right. Underground mining is how we get a lot of metals: lead, copper, gold. Anything that grows in veins. And metal tends to be found in veins underground. Underground mining is like chasing a ribbon. You know, you find the end of it, and so you dig so you can follow that ribbon through the soil. Tin, lead, copper, coal. Underground mining is really large scale nowadays, really common for large industrial metals. You see, if I say underground mining, you probably envision the black and white photograph, dudes digging a hole, get a donkey and some carts in there. But nowadays, this is your shovel, this is your cart and donkey. Most underground mines today are... Quiet sneezing is so gnarly. How do you do that? Does that hurt? I'm pretty sure I would poop if I did that. You poop? Wow. I can't hang with that. When I see kids do it, it like hurts. No. Nowadays, underground mines are usually classified by the size of the tunnel. So you get like a 15 or a 20 or a 30 or a 50, and they make machinery to perfectly fit those dimensions.
Is this the machinery that the Chilean miners were using when they got that?
I imagine, yeah. I don't really know any details of that mine. But almost all underground mining is done at this scale now. Up until the 1980s or so, this is how we design mines for coal extraction. Very helpful. Thank you, Maddie. Gabe really needed that. This is how we get, how we did our coal extraction in the past. Big old tunnels for it. Still, this is how we access vertical veins, especially for metals. And the big environmental consequences, the mining impacts for this one, are of course the water management, because you dig a hole in the ground and you got to keep it from filling with water. Wherever the water percolates, you get groundwater pollution. Wherever you leave the water on the surface, you've got a surface water challenge. And the risk to the workers. A lot of times there are collapses in tunnels and fires, explosions. Those can be really bad. Next is open pit mining. Now we're getting into the really large scale stuff. Here, instead of following the ribbon down into the earth, you just take the top off so you can expose your target. This is really common for metals, valuable things, large deposits. And remember I told you that we're reaching a new scale these days in mining. Here comes a perfect example. That's 4 kilometers across and 800 feet deep.
Is that supposed to be snow?
It is snow. And yes, they
What are you
think
trying to
powdered
make it look
sugar
like
for the
snow?
photos, yeah. They just poured a lot of spray paint.
What is that supposed to be? Snow?
That used
Are those supposed to be mountains? You're not fooling me.
What is this, ice?
So this fake snow represents real snow. I'm going to miss your questions next.
It's supposed to be a flame or fire.
Is it fire or flame?
So this is a big hole in the ground, and like when gophers dig a hole in your garden, this is all the dirt that you had to throw out to make that hole. Now, you can see the roads where the miners drive down into the pit. And when you look at those roads, it's really hard to put this into perspective. I think you remember we talked about this before, that your brain can't really visualize numbers bigger than 4 or 5. Have we talked about this? No. Okay, visualize 1 soccer ball. Visualize 2 soccer balls. Seriously, no. Visualize 3. Visualize 4 soccer balls. When I said 4, almost all of you would have done 2 by 2, taking a mathematical shortcut. But some of you might have visualized 4 in a line. That's okay. Now if I said visualize 8, it's almost a certainty that you cannot see 8 soccer balls in a line. In your mind's eye, if you try to hold them all. It's almost impossible. Like your eyes will start tracking behind your eyes. But watch. If I said visualize 16, it's basically impossible. I'd be shocked if anybody here, when I said 16 soccer balls,
Well, that's just because we've never seen 16 soccer balls.
didn't make them into a grid of 4 by 4. How many of you made them into a grid of 4 by 4? See? We're all using this mathematical shortcut because our brains can't do 16. It's too much. Think about it. In the environment where we evolved, why would we have needed the capacity for 16? What did you have to count?
Eggs.
There's either like a giraffe to eat, or 2 giraffes to eat, or plenty of giraffe. Who cares? We didn't have the need for numbers. We're not evolved to visualize large numbers. There's just no need for that. So when I say 800 feet deep and 4 kilometers wide, it's hard to put that into perspective, so let me try it differently. You can see that little mining road when you reach the bottom. You see that little yellow truck? So visualize the size now, given the scale of the truck, given the scale of that road. You know, the trucks have to go like this. It's a 2-lane. So in other words, if you're looking down at a similar mine, not the same one, looking down at a similar mine, you can see that road cutting down on the left. You can see how it's snaking along the left side of the photo. So maybe if that's a 2-lane road, that gives you some perspective. But I tricked you knowingly, because that yellow truck is not the sort of scale you were thinking of in the first place. Look at a Toyota Tacoma following the yellow truck. You see that yellow truck is out of scale with what you're thinking.
That's what I want to have for the zombie apocalypse.
Imagine parking there.
Because this is the, parallel parking at the mall. Because the scale of this is all staggering. It's the modern world of mining. So let's go back. If that's the truck, then that's not 2 lanes like you would imagine in your dirt driveway. That's 2 lanes like you'd imagine, the 405 next to LAX. Because it's 2 lanes for those big-ass things, which is like 8 lanes or more for consumer vehicles like we use. So now you imagine that road in a small mine, or visualize that same road in a much larger mine, and these are really big holes in the ground. I called my buddy Jesse the other day. I'm like, hey, dude, you want to hang out? He's like, yeah, hold on. I got to cover the hole with a tarp because he's been, fixing some plumbing in his front yard. He knew it was going to rain, so he had to cover the hole with a tarp. You can't cover that with anything. When it rains, that's a big, big, big funnel. What is that, a 15 square kilometer funnel? That's like a funnel the size of Santa Barbara or something. 4 kilometers across? That's pretty big, right? It's like 2 miles or something? So they do. The problem is, down at the bottom, you've got to manage these pools of funk. Full of sediment, full of acids from all that drainage. Full of, I'm guessing, drips of motor oil and stuff from the heavy machinery. So if you don't leave it at the bottom, you got to put it on the top, and we'll call it impoundment dams, and let that water evaporate off so you can concentrate the funk. But we're talking tremendous volumes. The part I'd like to emphasize for you, please, is the scale of these impacts. The volumes that we're talking about of groundwater and surface water.
These have to be built in the most optimal locations, though, right? This is a huge scale, and if you're dealing with incredible weather patterns that we've seen this
That just moves the scale of the impoundment ponds, but when you find the deposit, you got to go for it because that's where it is. So you don't choose the location of your mine; you choose the location of how you'll deal with the tailings and the water. I don't know about the ratios of product to extraction, of dirt to product. Next, students. Coal usually deposits in layers, because you remember that coal is an impurity in sedimentary rock. Strip mining is almost entirely for coal. And please look up. I dig a hole and put the dirt on the side. Then when I dig the next hole, I backfill the last one. When I dig the next one, I backfill the second. When I dig the next one, I backfill the third. So it's like a snowball effect of open pit. It's like a rolling open pit mine. This is the primary way that we take out coal. So there's a special problem because of the hydrocarbons associated with coal. That's a strip mine. You can see it's like an open pit, except it's like stretching in one direction as they follow that sediment layer. And finally, I want to talk about mountaintop removal, which is easily the worst impact of all. Remember that coal is a sedimentary deposit. So the way that we usually find coal in mountainous areas is like this. It's like a streak that runs along many mountains. Historically, we would make tunnels into that, like this. And just make tunnels to dig it out. But nowadays, we got a new plan. You blow up the tops of the mountains. You push them into the canyons. And then you get what's the equivalent of a parking lot with piles of coal in the middle. I'll show you some pictures. It's really hard to find good pictures of this. But you can see that we're basically reshaping landscapes. The habitat destruction here is obvious and massive.
Is that another one of those drives?
Yeah. You expose the pile so you can just drive right up and take the coal. The economics is awesome. It takes a very small number of workers, a very short period of time, to use just a few machines and expose millions of dollars of coal. For a while, this was the future of mining in America. This was the most profitable period in the history of the coal industry. And please remind me we left off here tomorrow, because that gets a bag on Andrew's favorite president, I think. Oh, second favorite. Yeah.
Did they like tell us about
Usually, yeah. Yes. No news yet about when I get my storage set. So. I know. Thanks.
That was so good.
Yeah.